Sketch a graph of r equals 44 over 5 plus 6 sine of theta. Use the graph to write the Cartesian equation for the conic. So in this problem, we recognize this, or should recognize this, as a conic, and the standard form for a conic in polar form is E times D over 1 plus E, and then either sine or cosine of theta, and this could be a minus. So matching this here, to get that, we're going to have to take this, and we're going to have to get rid of that 5, because we need a 1 right there. And so we're going to get that by multiplying both numerator and denominator by 1/5. Okay, so that gives us 44 over 5 over 1 plus 6/5 sine of theta. Okay, so now we see that E is equal to 6/5. E equals 6/5. So that's the eccentricity of the conic, which is, this is greater than 1, which means that we have a hyperbola. Oops, that's not how you spell hyperbola. Hyperbola. Okay, now, because this is a sine, we know it's going to be a vertically oriented hyperbola, meaning that the directrix will be horizontal, and our branches of the hyperbola will be moving away from it. To get some points and actually sketch this, we can just plug in some angles, and the easiest angles to plug in are the quadrant angles, the 0, pi over 2, pi, and 3 pi over 2. So we're going to go ahead and do that. So theta equals 0. We'll start with that. Now, sine of, and I'm going to use this one right here. So sine of 0 is equal to 0, and so we just get r equals 44 over 5. If we plug in theta equals, I'm going to jump to pi because I know sine of pi is also 0. So we'll get the same. We get the same thing there. We get r equals 44 over 5. We can also then plug in the other two angles. Theta equals pi over 2. And sine of pi over 2 is 1. And so we get 44 over 11. R equals that, which is 4. And if we plug in theta equals a negative, not a negative, 3 pi over 2. 3 pi over 2. Well, sine of 3 pi over 2 is negative 1. And so we end up with r equals 44 over 5 plus a negative 6, which is negative 1. So we get negative 44 for r there. Okay, so that's a pretty large number. I'm going to go ahead and sketch what we've got here. So when theta is 0, r is 44 over 5. And it doesn't, I'm not going to be super... I'm not going to be consistent as far as the scaling on the x and the y axes here because of how different, this negative 44 is. So on the horizontal axis, I think I'm going to go do a scale of 2 because 44 over 5 is 8.8. So that's going to be going 2, 4, 6, 8, and then 0.8 would be right around here. So when theta is 0, we get this point here. When theta is pi, we go the same distance but in the opposite direction here. So 2, 4, 6, 8.8 gives us a point right there. Okay, then we have these 2 points. When theta is pi over 2, we get 4, and 3 pi over 2, we get negative 44. So we're going to have to get 44 away from the origin. And so we can make each of these squares, let's make each square... I say 8. Let's make each square 8. So at pi over 2, we're just going to go half of that square, because up to 4, right? But then at negative 3 pi over 2, which is in this direction, we get a negative number. So we actually then go up, okay, the opposite direction from that because of the negative. And since each of these is 8, we're going to go 5, 1, 2, 3, 4, 5 and a half. That gives us another point. Okay, and in this form for a conic, we know that we're always going to have our curve will be kind of wrapping around the origin because the origin is a focus. And so we get something that looks something like this. Okay, and of course it's going to look similar up here. Okay, there's our hyperbola. It's not super important that it looks nice here. What we're trying to do is use the graph to write a Cartesian equation for the conic. So this is a hyperbola that's vertically oriented. So we know that our standard form is y minus k squared over b squared minus x minus h squared over a squared equals 1. hk is the center, and I can get the center here. I know that's just halfway between these 2 points. Now I'm going to switch to Cartesian and write what these points are. This here was at 0, 4, and this was at 0, 44. So halfway between those, I just need to get the average of those. So the average of 4 and 44 is 24. So this right here is at 0, 24. Now that's h and k. So that brings me to, I have y minus 24 squared over b squared minus just x squared over a squared equals 1. Okay, next we're going to look for either a or b, and I see here that the distance from the center to a vertex, that's going to tell me b, because I've got that vertical distance there. That distance I see is 20, and so that's going to be b. So I have y minus 24 squared over 20 squared, and then minus the x squared over a squared equals 1. Finally, I need to get a, and I can use another point to get that. And to get that, x can't be 0, otherwise it would cancel this term out. But I do have these points here. And so I'm going to go ahead and use this point right here, which was over at, let's see, that was at the 44 fifths. 44 fifths, comma, 0. And so we can plug that in for x and y, and then solve for a. So let's go ahead and do that. We have 0 minus 24 squared over 20 squared minus x is 44 fifths, so 44 fifths squared over a squared equals 1. Okay, and then we need to solve for a squared. I'm going to go ahead and move this whole fraction over to the right side because I don't like that negative, and I'm going to move the 1 over, subtract that. So I get a 24 squared over 20 squared. 24 squared over 20 squared minus 1 is equal to 44 over 5 squared all over a squared. We can simplify this a little bit. First of all, 24 over 20, that can reduce. That's 6 over 5, and then squared is 36 over 25. Minus 1 is 25 over 25. And then we've got squared over a squared. 36 minus 25 is 11. So we've got 11 over 25 equals this fraction. Now I'm trying to solve for a, so I'm actually going to take the reciprocal of both sides, and that's going to give me 25 over 11 equals a squared over 44 over 5 squared. Then we can multiply both sides by that there, and so we get our 25 over 11 times 44. I'm going to go ahead and write this as 44 squared over 5 squared equals a squared. Because now 5 squared is 25, so that cancels. And 44, I'm going to rewrite that. That's 11 times 4, and it's squared, so I'm going to write another 11 times 4. And I just do that because now one of the 11s will cancel. And that's going to be our a squared. I actually don't care what a is because I'm just looking for the equation for this, and here's my equation. I just need to know what a squared is. So I have a squared here. This is 176. And so now that's a squared, so I can take that and plug that back in up here. And I go ahead and I get my final Cartesian equation. I'll go ahead and write it out. 20 squared is 400. And then minus the x squared over 176 is equal to 1.